this is Jo from Maths Tutor Me. Today we're doing factors, multiples and indices, and we're going to be finding prime factors. Now, prime factors of a composite number are factors of the number that are prime. Okay, so it's kind of in the name. Prime factors are factors that are prime. A factor tree is one method that we use to find prime factors. Okay, so in the examples, for the following numbers, find the prime factors using a factor tree, list the prime factors of the number, and write the number as a product of its prime factors in index form. Okay, so my first number is 63. So I'm going to show you how to make a factor tree. We take the number 63 and we need to find two numbers that multiply together to give 63. So the numbers that I think of straight away are 9 times 7. Now, if either or both of any of the numbers that you've written down there are prime, you circle it. So 9 is not prime, but 7 is. So I can circle that number and that number is finished. If it's not prime, I need to find numbers that multiply to give that number. So 9 can be written down as, I branch it out again, 3 times 3 is 9. 3 is a prime number, so I circle both of those, and that is the end of my factor tree because all of my branches have been finished with prime numbers. Okay, so now that we've done the factor tree, which is part 1, part 2 is to list the prime factors of the number. So the prime factors that we have found are the circled ones. So there's only two numbers. This one just happens twice, but the numbers are 3 and 7. Okay, and part 3, write the number as a product of its prime factors in index form. So that means that 63, the number that I started with, is equal to, and I want to write these numbers in index form. So I have 3, but there's 2 of them, so I can write that as 3 squared times by 7. Now, if you wanted to check, you could get your calculator and you could type that in. 3 squared times 7 is equal to 63. All right, let's do that all again for B, which is the number 300. First of all, let's make the factor tree. So what can we think of it that times is to give 300? Well, 3 times 100 seems like a nice easy place to start. 3 is a prime number, so we circle that number. 100 is not though, so we need to keep going. 100 could be written down as 10 times 10. Now you can choose different numbers here. You will end up with the same result though. Okay, still these aren't prime numbers, so I need to keep going. 10 can be written as 2 times 5 and 2 times 5. Now they are prime numbers. So that's the end of that branch. Everything's been finished off, so that's the end of my factor tree. Now we need to write down what the prime factors are. So prime factors, I have the number 2, 3, and 5. 2, 3, and 5. So let's write the number 100 as a product of its factors. 2, I have 2 of them, so 2 squared times, there's 1 3, times 5 squared because there's 2 of them. Okay. Question 2, consider the numbers 72 and 108. Use a factor tree to write each number in index form. So we need to do the number 72 first. So let's break that down to be, let's just go 2 times 36. Okay, 2 is prime, so circle it. But 36, we could change that to be 6 times 6. Or you might choose 4 times 9. Lots of different choices. Okay, and still not prime, so let's keep going. That would be 2 times 3, and that would be 2 times 3. Now they are all prime, and we stop. So to write it in index form, 72 is equal to 2 to the power of 1, 2, 3 times 3 squared because there's 2. All right, let's do that again for 108. 108. Sometimes with bigger numbers, it's just easy to divide by 2 for a start. So that will be 2 times 54. Okay, so that's circle the 2. That one's prime. 54 is the same as, let's do 9 times 6. 9 can be 3 times 3. They're both prime. We can circle them. We haven't finished this branch over here. 6, we can go to 2 times 3. They are both prime. So now that everything's finished there, that means we can write 108 as 2 to the power of, there's 2 of them, 2 to the power of 2 times by 3 to the power of 1, 2, 3. Okay, now what we can do if we have 2 factor trees like this, we can use them to help us find some things. So one of the things we want to find is we want to find the lowest common multiple of the numbers. So what we want to do is we want to take these factors that we've got and we want to take the biggest power of each factor. So for example, they both have 2 as a factor, but we'll take the one that has the biggest power. 2 to the power of 3 is the bigger one. And they both have 3 as a factor, but the bigger power is this one, which is 3 to the power of 3. Now, if we multiply that together, that will give us the lowest common multiple of those 2 numbers. So we type that in, 2 to the power of 3 times by 3 to the power of 3 equals 216. Okay, and that's the end of that question. Time for you to practice. So here are some questions, just like the ones I've shown you. Pause the video, give these questions a go, and then restart to see how you've gone. So for question 1, we want to look at the number 288. Find the prime factors using a factor tree. So 288 is our number. We want to make the factor tree. So again, it's a big number. It's an even number. Let's just divide it by 2. So that'd be 2, which is prime, times 144. 144 is a number that we probably recognize, or hopefully recognize, as 12 times 12. Okay, they're not prime. We need to keep going. 12 could be 3 times 4. Or we could do 3 times 4 here, or let's just be different and we could do 2 times 6. Okay, that one is prime and that one is prime, but these ones need to keep going. 4 is 2 times 2, and 6 is 2 times 3, and they're both prime. So you can see, even though we started with 12 for both of these, and I chose different numbers, I still ended up with 1, 3, and 2 2s, 1, 3, and 2 2s for each one. So you end up with the same result. So there's my factor tree. Part 2, list the prime factors of the number. So my prime factors, I had 2 and 3, that was it, 2 and 3. Part 3, write the number as a product of its prime factors in index form. So that means that 288 is equal to 2 to the power of 1, 2, 3, 4, 5 times by 3 to the power of 1, 2. Okay, that's finished that one. Question 2, consider the numbers 294 and 504. Use a factor tree to write each number in index form. So 2 factor trees coming up. We want 294 as my first number. Now sometimes with these big numbers, I could divide that by 2 again. You might also want to try things around on your calculator. This time I'm going to do it a little bit differently. I'm going to change that to be 7 times 42. Okay, that one's prime. 42, I need to keep going. That's 7 times 6 or 6 times 7. Okay, 7 is prime and 6 is going to be, I'm going to change that to be 2 times, 3. And they are both prime. Okay, now for the number 504. All right, 4 on the end, so let's try dividing that by 4. So that's 4 times 126. Okay, 4 is 2 times 2, so that they're circled, they're prime numbers, but we need to keep going with 126. 126, you can change that to be 9 times 14. Again, you can use your calculator to find these numbers, or you could just be dividing that by 2 if you wanted to as well. And 9 is 3 times 3, and 14 is 2 times 7, both prime. Okay, so they're the trees. We wanted to write them in index form. So 294 is going to be equal to 2 times 3 times 7, 2 of them, so 7 squared. And 504 is equal to 1, 2, 3, so 2 to the power of 3. We have 3 squared and 1, 7. Okay, so now using those trees, we want to find the lowest common multiple of the numbers. So the lowest common multiple, looking at each of my factors and writing down the biggest one. So 2, okay, 2 to the power of 3 is the bigger one here. So that's 2 to the power of 3 times by 3. So this one's bigger again. So it's going to be 3 squared times by